All right, so part two is to create the flow diagram. So to do that, we are going to use our PNID, our Brains, and Visio. You can use other applications to make the flow chart. I just prefer Visio. It's pretty simple to use. So in Visio, we create a new basic flow chart. That'll give us our starting point. So for this, we're going to start at an idle state. So we bring in a start point, a circular one here. This is step 0, idle. So we think about our system, and this is going to be started automatically. So it's not going to have any user input to start it. And it's going to be started automatically from either a call from the system feeding it or a call from the system that it wants to get stuff from. So we get a choice in here. That's the triangular one. And we're going to use this system start call. That is going to be a flag type. So we'll just call it a flag. So if it gets a system flag, it will go through another check, and it will check interlocks and permissives. So it'll check our interlocks and permissives, things like having valves in manual and the pump is not faulted out, things like that. So if it gets a no for if it doesn't get a start, and it also doesn't get through the check for interlocks or permissives, it will go back to the end here. So you can put a path for no here. And this was a yes path. If we pass our interlocks and permissives, we're going to start up and we're going to go to the next step. So each step is specific to the outputs that it has. So the inputs of the system allow it to change steps, and then each step has its own set of outputs. So anytime we need our system to have different outputs, that means we need to have a different step. So our idle is going to be basically everything is off. So all the valves are shut, the pumps are off, the glycol's off, all that other stuff. And then when we see it start up, what we're going to do is we're going to change our outputs so that we are doing something specific. So we have 128 steps to do, 0 through 127, that we have available. And it's good practice to skip a few steps in between just in case we need to add something in the future. So we will do a step 5 here. And in step 5, what we're going to do is we're going to lower the tank level to 0. So lower tank level. Doesn't necessarily have to be 0, but a set point that is defined by the system. So now we're going to have our outputs that are going to open up the drain valve and open up the outlet valve to allow that any water or anything like that to drain out. And we are in an idle state. We assume that we're clean and we're moving forward from there. So now we have a decision to make. Our decision is tank is empty. And we know the tank is empty if we lose our low level switch here, or we could also use our level transmitter if we wanted it down to 5% or 3% or something like that. So we can decide that later during our actual transitions. This is just going to be a flow diagram for human readable. So if our tank is not empty, we have a feedback loop here that is going to go back to this step 5. And then if it is empty, we're going to move to the next step. So our next step, we're going to do step 10, skip a couple. And this is going to be basically an idle position. So waiting for either a product feed or waiting for a product call from the system in front of it. So this will allow our cooling to work and our agitator to work in this step in case we have a level. So this one, we'll call it waiting for product flag. So we have a product flag that we're waiting for, and it's going to either be a call from the system in front of it or a send flag from the system behind it. So we have a decision to make, a couple of them. We have a product call flag. So we're going to get a product call flag from the system in front of it. And then we have a second decision to make. That is going to be a product send flag. And then we have our feedback loop goes back to step 10 if none of those exist. So we have no and a no. And there's a few different ways you could do this particular one. But I feel like the easiest way is to just going to be calling for them. So once we receive one, we might receive both of them at the same time. But once we receive one, then we can move to a next step. So let's say we get our product call flag. So we're going to get a new step. And this is going to be step 15. We're going to call this production product send. So this one, we're sending the product out to the next system. And then we could get a yes from this one here. We'll call this step 20. Product production product receive. I'm an engineer, I can't spell. So now our decision needs to be made here. We have a production send, so that's a singular. We have a production receive. And then we're also going to have one where both of them exist. That could be an also state. So that'll be step 25. Production send and receive. And we're going to move in between these steps based on whether or not our calls exist from the next one. So we have a lot of different decision-making things going on here. So I'll kind of explain a couple and then we'll move on to the next video. So we can get a product shouldn't send, we can lose our product call. So lose product call. We could also gain our product send. So if we get our product send, we're going to go into product send and receive. And then if we lose our product call, we're going to revert back or revert to step 10 here. And wait for our product call. And then we'll have similar ones from step 20 and step 25, and we'll address that as we make it, and then we'll pop back up for the next video.